Good afternoon, everybody. My name is Atil Talay. We prepared a study about analyzing operational energy efficiency techniques for reducing carbon dioxide, especially for tanker vessels. This is in Nigro. Actually, this is an ongoing study, and we have extension of study in the future, and we are planning to publish this study in a journal. And what did we do? First of all, I would like to give you an overview of the greenhouse gas emissions and effects through the atmosphere and the environment. Then I want to give another overview about the operational carbon dioxide reduction measurement for tanker vessels. As we know that you cannot apply all efficiency techniques for all type of vessels. You have some application for containers, some application for cargo ships, bulk carriers, and I specially selected this technique for tanker vessels. Then we have an experiment, an operational experiment, which we apply constant full mission in given simulator, focusing on the speed reduction and optimization operational techniques. We were able to see the fuel consumption under different loads and different speed variation. We were able to see the fuel consumption changes when we change the load. And we were able to calculate the annual, we were able to calculate the trip here, the voyage time. And we were able to calculate the number of trips per year with this simulation. So I would like to talk about what we can do with this simulation in the future at the end of my presentation. So to overview, you know that maritime transportation is responsible for the carriage of 90% of the world trade. So we have problems. What is the problem? According to International Maritime Organization, according to Maritime Policy Convention, Annex 6, what else? So we need to decrease the emissions, right? So what are these emissions? These emissions are sulfide, particulate matter, and carbon dioxide. In this study, we focus on greenhouse gas emissions, which also mentioned as the carbon dioxide emissions. So I have been studying about this subject like 8-9 years. When I just started to study about this, we were talking about global sprint is responsible for the 3.5 or 3.3% of the carbon dioxide emissions. When I see the updated data, it decreased to 3%, so it means that we are successful expansion. So we have implementation about carbon dioxide reduction methodology since 2011. IMO also organized annual report with the carbon dioxide greenhouse gas emission measurement report. Now we have some targets starting from today. By 2030, we need to decrease the carbon dioxide emissions by 30%, 40%, and 2050 target is decreasing the emissions by 70%. I don't know what you think about non-zero shipping, non-zero emission shipping, but for me, I don't believe. So, of course, we have some references to do this evaluation. For example, you know that energy efficiency design index is a kind of equation, right? So this equation includes the capacity, the load, the fuel consumption, and the complex equation. And we have another methodology that we need to follow, ship energy efficiency management plan, which we apply for the ship. We also follow this direction while doing our study. we first of all we created a data table for the operational efficiency, energy efficiency application. And the values of the data is taken from the public data. What are the public data? IMO publication, PNV, ABS, ABD, what's Pila. I like to watch Pila's classification about the energy efficiency technique, like, they classified like we have some applications for new design of this. We have some applications for propulsion, which also, connected with or related with the fluid mechanics application. They have another application for machinery, and the last classification of their topic is operation and maintenance. We took the operation side because I just hope that if you folks in the lines that you write that okay, we are applying this reduction methodology, but nobody thinks about the ship owner, right? Nobody thinks about this company. So application creates an expense for the ship owner and the company. So we need to think about that too. So actually, it will affect the price rate and it will affect the prices of the things that we use in our life. So in evaluation, what did we do? We have engineering simulator here, a 2 point, and we have several engineering design. We selected 2 engineering design, which is one of them is steam power plant engineering design. The other one is diesel power plant engineering design. Diesel power plant has 2 medium diesel engines for operation. Actually, we use this simulation software for training of the students. It is required for the IMO and the CW law. We can see the remote panel for steam and diesel engine here. And let me talk about the overview of the operational energy efficiency for tanker vessels. So we evaluate weather routing and void planning. Weather routing is very important. So we need to count the weather conditions, seasonal conditions, and do our routing and void planning to increase the efficiency and lowering the fuel consumption. On-time arrival and effective cargo planning at port constitute the part of weather routing. Another subject that for operational energy efficiency application, trim, draft, and ballast optimization. You know that trim optimization is a very good indicator between the hull resistance and the fuel consumption. So we need to take this into operational efficiency applications too. And void speed optimization, we focused on this in our study. We focused on this because then I think we are towards speed optimization. I don't know what you think, but speed optimization should be the right word for operation application. So if you decrease the speed of the vessel, what can happen? The hull resistance again will decrease and the required power will decrease. So we're gonna emit low carbon dioxide through the atmosphere. Another indicator for our study is autopilot adjustment. So if you have autopilot installed on your vessel, we can apply this as an operational technique. And for optimal adjustment and use of autopilot, best practice in shipboard procedures must be implemented, including recommendation on optimal number of rudder movements and angles for different sea conditions for all voyages. So I think it will be in the voyage planning too, autopilot adjustment. And another one, power management. During the maneuvering operation, arriving to the port, departing from the port, we are playing with the generators, right? We need to double the generator, and we take off one of them. And so this is another option for decreasing the fuel consumption and increase the energy efficiency. Turnaround time in the port, arriving to the port, departing from the port, loading, unloading, mooring, and other operations including. If you decrease the turnaround time in the port, it means that you're going to increase the efficiency again. But how are you going to decrease? If you have a power plant which has high maneuverability, what's going to happen? You will be able to increase the efficiency. So the best option for this will be as possible, as efficient. And another one, energy saving operational awareness. It starts from the crew, the company. Actually, training is very important. We need to apply and teach how to be aware for the energy saving during the operation of the ship. Overall, we created a table. What does table show us? The effects of weather ruling and voyage planning reduce the carbon dioxide range 5 and less. Clean draft and balance optimization 10, 5 and less. Void speed optimization 23% and less. 23% means that if you decrease the speed around 3 knots, you can have this value. Autopilot adjustment 1.5, turnaround time in the port 10%. This is another big indicator, right? So 10% is a good amount of reduction of the carbon dioxide. Energy saving operation availability 10% and power management. So if I would like to focus on the speed reduction technique, so as I told you that requires power decreasing, power decreasing, but we have some negative effects. So we have some disadvantages. If you decrease it, what can happen? The period of the trip will be increased, right? So we need to have a correlation between the trip time and the speed. So, for example, we will create a model if we have high freight rate in the market and high fuel oil prices. Right? So the company will save. So we created a case study. We had port A, we had port B. Between these ports, we have 4,000 nautical mile distance, and we operate 2 different engine modes, one steam plant, the other one diesel plant, and steam plant. More of them are tanker, of course, because we have simulated tanker vessels. The first plant specification, as you see on the screen, the steam power plant, operating with dual fuel, heavy fuel oil and LNG. We have dual boilers on this plant. We have 2 diesel, 2 turbo generators. Main turbine maximum power output is 27,000 kilowatts. And service speed of this vessel is 19.5 knots. The second tanker vessel, model M22, medium speed diesel, max type of diesel engine. We have 2 diesel and 2 power takeoff generators and the electric power plant. Maximum continuous rating is 11,760 kilowatts. And service speed of this diesel is 20 knots. And you can see this ship on this case. The advantage of this simulation and constant simulation You can have different options to operate and see the fuel consumption. What is the option? For example, if we have a steam power plant, you can operate the steam power plant and fuel oil. It is on a turbo generator. Or you can operate the diesel steam power plant, heavy fuel oil and LNG with diesel and turbo generator. I mentioned it here, option 1 and option 2. For the diesel power plant, we have more options. We have 4 different modes. We can operate this power plant with heavy fuel oil for main engine, marine diesel oil for diesel generator, and we use diesel generator as power mode. Second option, we operate the main engine with heavy fuel oil, and we don't have diesel generator in this option, and we directly continue operating with power table with heavy fuel oil. Another option, marine diesel oil for main and diesel generator, and another option, marine diesel oil for main engine and power table. When we started, we studied last year, the prices were very different. The land increased a lot. So marine diesel oil, a lot of changes day to day. Heavy fuel oil, that we heavy fuel oil to last fuel oil. So a lot of different conditions we had. So these options create a different opportunities for fuel consumption during the operation of the shipping. In our study, we assume that port days are 5 days. Loading, unloading. You can decrease it to 4 days too, but for this study, we apply 5 days and 4 days. Then, as you see on the table for vessel 1, which one is vessel 1? Steam power plant, and vessel 2, diesel power plant. We operate the power plant under different roles, starting from 50% to 100%, and this peak, for example, 50% load, we have 14.7 knots speed of the vessel, and 100% of the load, we had 22 knots speed of the vessel. But when I checked the average speed of the tanker all over the world, I saw that average speed normally 11.5 to 12.1. And for the diesel one, we did the same thing, and the simulation gives us the for different loads for different speeds. Okay. So when we check, for example, when you decrease the speed from 20.8 to 18.15 knots, what do we see here? We would decrease the load from 85% to 80%. And the fuel consumption, actually, we don't use any more diesel oil over 75% load. Steam power plant is only operating with the LNG. You can see the difference. We save 5.42 tons per hour during the operation of this steam power plant. If you decrease 5% more. So we can see what's happening with the speed reduction and effects on the fuel consumption for cycles. For example, for the diesel one, they do the same thing. Take the load from 90% to 85%. Speed will decrease around 1 knot, and the fuel consumption will decrease 0.7 tons per hour. So it's a good opportunity to see that in the simulation. Another thing that what did we do? We need to find out the total fuel consumption per trip, right? So we do our calculations for per trip. So We have this equation. We found the total time at t, the length of the speed over 24 times the speed. Once we have 24, the conversion of the days and the hours, we need that number. And we assume that again 5 days for time for this operation. Another calculation, we need to find the total fuel consumption per trip for making estimations and the prediction. And then we created another data table. What is the data table? Under different trips, under different speeds, how long per trip takes? For example, if you operate your ship 14.7 knots, what can happen? 4,000 nautical miles, we have 11.34 days per trip. If you operate your ship 20, let's say 18.5 knots, it decreases 9 days, and we don't have any heavy fuel consumption. This is the best optimization. And we have only LNG fuel consumption, 970 tons for all the. You see that with the simulation. And what else do we have? We calculated the difference of voyage time. So what happened? What is the difference? If we and we saw the difference of fuel consumption for both. So what is the next one? Assuming 5 days or time and calculating the total time per trip, you will be able to see the number of trips per year. So if you operate, it should be different on the different speed. You can see the number of trips annually per speed condition for water. So time per trip is including the time for example, we talk about 18.5 was the existing one, right? 18.5, 9 days per trip, 14 days, including 4, you will be able to do 26 trips per year with this. So, of course, we have extension of this study. What is the extension of this study? We can count the freight rate, and we can also change the operation times and fuel consumption, changing the load and the speed. Another thing, it is not that easy. The 4,000 knots from Europe, the United States, no. If you think about an oil tanker, generally receive the product from the Middle East and bring to the United States, right? So we have different route conditions. For example, we are passing through the Suez. You cannot increase the speed over 7 knots while passing through. So we need to calculate this option with the fuel consumption if we create on the speed. For example, you are passing through Gibraltar. You cannot go over 20 knots while passing through Gibraltar. You can do it. Or if you are passing by the pilot, region, you shouldn't decrease the speed below 18 knots. Dangerous. So again, you will be able to use this table to calculate the fuel consumption. But let me tell you something. It's an ideal point. If we will have opportunity to connect this engine room simulator to the bridge simulator, we will be able to create the other operational conditions. What are the other operational conditions? The bridge simulator, you can create the weather routine, right? Voice plans, right? Power management, right? I don't know energy arrangement, but you can create or autopilot examples, right? So we will have more chance to see the real situation for the fuel consumption and the carbon dioxide. What is the outcome of the study? This is a big factor to reduce carbon dioxide emissions. Actually, this is the cheapest methodology, right? To decrease the carbon dioxide emissions because you don't need to invest anything. Only decrease the speed and continue operation. Another area saving awareness and turnaround time is another important option. We have chance to use engine simulator. As I told you, you can connect to the simulator. It's going to be more effective, more accurate. So I want to read that sentence. This is important, but I wrote it. So, the results suggest that speed reduction under certain conditions is beneficial in terms of reducing emission, but real effectiveness of such a scheme depends on port time, freight market, and fuel price. So you can optimize everything in this condition. As long as you know how much you consume, you can control the voyage and the carbon dioxide emission. I'm not only thinking carbon dioxide emission. I'm thinking the ship owner side and the company side. So what will be the fourth further study? They are being conducted to investigate the variation in specific fuel consumption with engine load. Future study will be depending on cost-benefit analysis with each fuel consumption fuel prices trade rate. This includes specific form under different speed and emission limitations. Plus, one more thing, the EEDI numbers. With this variable data, we can calculate the EEDI number, and we can show that IMO, this is my EEDI number, I'm operating my ship under this. Thank you so much.